hope you're doing great. In this video, we want to talk about precipitation reactions, which, as we have talked about different kinds of reaction in another video, it's a kind of double replacement reaction. So basically the principle of precipitation reaction is that we should have two aqueous solutions that add together, and we will have a solid compound plus whatever else, it doesn't matter, but we need to have a solid compound for production. Okay, look at this example. For example, AgNO3 plus CaCl2. So as you know, because they are ionic compounds in water, they completely separate to each other. We will have Ag plus and NO3 minus and Ca and Cl minus. So all of them should be in ionic form when they are in aqueous form. So now, because it is double displacement reaction, it means that both compounds should change. So here, Ag instead of NO3 will be joined to Cl minus, and we will have AgCl. And the NO3 will be joined to calcium, and we will have calcium NO3, as you see here. The next step will be finding out, do we have any solid compound or not? So for doing so, you should know some rules, like some solubility rules, that the two of most important ones you see here now. All of compounds that have NO3 nitrate compounds are always soluble in water. So whenever you see something like X, but it ends with NO3 at the end, this is for sure aqueous. The other thing, chlorides are usually soluble with some exceptions. If chloride are with Ag, Hg, or lead, these compounds will be insoluble. Here we have chloride, but it's one of those exceptions. It's with Ag silver, so this is the solid compound. We had two aqueous and a solid, so it means that precipitation reaction. So for precipitation reaction, we should know how to write net ionic equation. What does net ionic equation means? For writing net ionic equations, first of all, we have to write whatever we have separate here, like Ag, Cl, NO3, and Ca in ionic form. It means that with their charge and their phases. So as you see, we have two Ag plus, two NaO3 Y2 because they had two coefficients. So we don't forget, we should distribute these two. When we have two AgNO3, we have two Ag and two NO3. As we had CaCl2, so we have one Ca and two Cl minus. And also you see the rest of the equation. In writing in net ionic equation, we have two components. One of them is observer compounds. What are observer ions or compounds? Are the ones that exactly repeats in both production and reaction, like NO3 here, that we cancel these two together to write the complete net ionic equation. And also the calcium is here, the observer too. By canceling the observer, we will have the net ionic equation, which gives us exactly the precipitation reaction, which is the Ag, aqueous, the Cl, aqueous, and the solid form. So deleting the observer compounds to get at the end the net ionic equation is actually writing the precipitation reaction that happens. Let's look at another example. So in this example, we have PbNO3. As we see, the NO3 has this 2. It means clearly that our Pb charge was +2. And NO3, because we know that is, which is -1. For writing the expanded form, we will have 1 Pb2 and 2 NO3. We have NaBr, which is aqueous, and you know that Na is +1 and Br is -1. Then we have for the result, because it is double displacement reaction, so the Pb will be joined to Br, and we will have PbBr2, which is our solid product because this is a precipitation reaction, and NaNO3, that because of nitrate it is aqueous for sure. Now, what are the observer ions or compound? The observers are, as you know, the NO3 cancel together, and the other one is the two sodiums. So what are left? We have Pb plus 2 in aqueous form plus 2Br, that the result is PbBr2, which is a solid product. So this is a net ionic equation and also the precipitation reaction which occurs in this equation.